Place an object on a rough floor and apply an external force F, the force of your finger, in the horizontal direction. If the external force F is small, the object won't move, right? This is because a static friction force F acts in the direction opposite to the object's attempt to move away from the floor. So, the static friction force F acts in the opposite direction to the one in which the object is trying to move, right? Since the object is at rest, the forces acting on it are in equilibrium, right? The equation for the equilibrium of forces is as follows. Vertical direction, N equals mg. Horizontal, F equals F. Based on the horizontal equilibrium described above, if we increase the external force F, the static friction force F also increases, right? And then, finally, pay close attention to the moment the object starts to slip. The static friction force F acting at the moment the object starts to slip is at its maximum value, max, right? This maximum value, denoted as F max, is proportional to the normal force acting on the object and can be expressed as follows. Maximum static friction F max equals nu n. The symbol nu, mu, that appears in the equation above is called the coefficient of static friction, and it takes on various values depending on the combination of the floor surface and the object. Less than examples of static coefficients of friction, nu, greater than. Glass and glass, dry, 0.94. Steel and steel, dry, 0.7. Steel and steel, oiled, 0.1. F. You treat the static friction force as F equals nu n, you're wrong. Only the force acting right before the object starts moving is F max equals nu n. As shown in the following figure, when an object slides across a rough floor, a kinetic friction force, F, acts in the direction opposite to the direction of motion, i.e., in the direction that resists the motion. The magnitude of the kinetic friction force, F, is proportional to the normal force, N, and can be expressed as follows. Kinetic friction equals F, equals mu, N, constant. Mu is coefficient of kinetic friction. The maximum value of static friction is denoted by F max equals mu N, right? Note, however, that kinetic friction is a constant force that does not depend on velocity or the magnitude of an external force. The mu that appears in the above equation is called the coefficient of kinetic friction, and empirically, it is smaller than the coefficient of static friction, mu. Problem. As shown in the figure, an object of mass m, kilogram, is placed on a slope with an angle theta. As the slope angle theta was gradually increased, the object began to slide down the slope when theta reached theta 0. Let g be the acceleration due to gravity. Answer the following questions. 1. Determine the static friction force F and the normal force N acting on the object at the instant it begins to slide down the inclined plane. 2. Determine the coefficient of static friction mu between the inclined plane and the object. Answer. The forces acting on the object are gravity, mg, the normal force, N, exerted by the inclined plane, and the static friction force, F, that's 3 forces in total. Let's break down gravity into 2 components, one along the slope and one perpendicular to it. Since the object is just barely at rest at theta equals theta 0, the forces acting on it must be in equilibrium. Based on the equilibrium in the slope direction and the direction perpendicular to the slope, F and N can be calculated as follows. In the direction of the inclined plane, static friction is F equals mg sine theta 0. Perpendicular to the inclined plane, normal force, N equals mg cosine theta 0. Since it says that slippage began when theta equals theta 0, the static friction force F reaches its maximum value, F max equals mu N. Substituting the result from 1 into F equals mu N gives the following, mg sine theta 0 equals mu mg cosine theta 0. From tangent equals cosine divided sine, The coefficient of static friction is tangent theta 0. Mu equals tangent theta 0.